die from a sort of internal drowning.
With water flooding the pipes, time was running out. The tank should have been protected from contamination, but a catalogue of failures was about to have the most terrible consequences for the people of Bhopal. The tragedy at Bhopal happened when some 35 tons of a lethal chemical called methyl isocyanate reacted with water and vaporized. Thousands of people in the shantytown that surrounds the plant were gassed, dying in the same horrific way that soldiers were killed in the First World War. The disaster was due to an amazing combination of circumstances. Had each happened on their own, the accident would never have occurred.
In terms of designing chemical plants, there are really two sorts of safety. One is designing the plant to be safe in the first place, and the second is operating it safely. And at Bhopal, there were problems in both areas.
3 hours to go until the catastrophic release. The first of many hundreds of litres of water found their way from a routine cleaning operation into the main pipe system that ran throughout the factory. It should have been impossible for the water to get very far, but mistake number one had already been made. A safety procedure existed to isolate sections of pipeline before they were cleaned. A simple piece of metal called a slip blind is inserted and the bolts done up tight, achieving an impenetrable seal. Incredibly, this procedure was often ignored at Bhopal.
To install a strip line like this would probably take about 2 hours, and you would have had to wear a lot of protective clothing, because when you undid the bolts of these flanges, the possibility of chemicals splashing onto you would be there. If one of these small pieces of steel had been inserted into the process pipeline, in all probability this disaster would not have happened.
By 9:30, the water was able to travel freely through the hundreds of meters of pipe that separated the main plant from the MIC storage area and its deadly content. The disaster could still have been averted, however, had the gauges in the factory's control room been trustworthy.
When this plant was designed and installed, the instrumentation here was probably state of the art as far as India goes. Over the years, lack of maintenance contributed to the instruments giving faulty readings from time to time, which probably led to the operators and to the staff not taking the readings very seriously.
MIC is kept under pressure with inert gas to stop anything from getting into the tank. But for 6 weeks, the pressure gauge had read virtually zero. It was presumed that the gauge was faulty. In fact, there was a leaky valve connecting the tank to the plant's main pipe system. If gas could get out, then water could get in. By approximately 10 o'clock, the contamination had started.
The reaction of MIC and water generates carbon dioxide as one of its products. It also generates heat. Of course, the heat starts to warm the mixture. It's an exothermic reaction, as we call it. What I'm going to do is a similar reaction that obviously uses much safer chemicals. This material is going to behave rather like the MIC did. The material I'm adding is in effect the water that came into the vessel. We add that, and as you can see, gas bubbles start to form.
Water is denser than MIC, so it falls to the bottom of the vessel. The first part of the reaction takes place where the two layers of liquid meet.
So this looks exactly like the MIC water interface would. We're generating bubbles at the boundary between the two liquid layers. But the key issue is the heat. This heat heats up the reaction mixture. The temperature rises, and when the temperature rises, the reaction speeds up, and in turn generates heat even faster. It's what we call a runaway.
Even with water in the tank, it should have been possible to control the situation. MIC has to be kept cool, and the tanks were housed in a concrete bunker, insulating them from the fierce heat of central India. There was also a cooling system controlled from a purpose-built refrigeration plant. The senior management, however, had decided to switch it off.
This wasn't running on the night of the tragedy. In fact, it had been off since May '84. The coolant inside had been removed and it was permanently disabled.
Switching the refrigeration off was an insane thing to do. These reactions, these exothermic runaway reactions,